Hello and welcome back to the Networking Fundamentals section of this course. In this video, we'll be discussing TCP and UDP and comparing them as being a connection-oriented protocol versus a connectionless protocol, and talking a bit about what that actually means and some of the technical details of TCP and UDP. So first up, TCP. TCP is the Transmission Control Protocol. That's what TCP stands for. The Protocol Data Unit is the segment. So TCP segments are sent and received. The size of the TCP header is 20 to 60 bytes. Its minimum size is 20 bytes, and it can be as large as 60 bytes. The first TCP message that is sent starts with a random initial sequence number. And the TCP header includes both a source and destination IP address and port number. So over here on the right, we have a cutout of the TCP header. The first 2 bytes we see are the source port, and it calls it a port address. It's actually a layer 4 address. Recall, right, that layer 2 is our MAC address. Layer 3, we have our IP addresses. And at layer 4, the addresses we use are ports. So we have a source port that is 2 bytes and a destination port that is 2 bytes. We also have a sequence number. This will be incremented as the transmission continues, and it starts off with a random initial sequence number. And we also have a 4-byte acknowledgement number. Now, the acknowledgement number is the same length as the sequence number because the acknowledgement number is a sequence number, that to acknowledge that a particular sequence was received, this acknowledgement number is set to that sequence number that is being acknowledged. Further along the header, we have the HLEN 4 bits field, a reserved field that is 6 bits, and then we have a couple other items that we're actually interested in here. A few flags that are 1 bit each. The urgent pointer or flag, the acknowledgement flag, ACK, the push flag, the PSH, the reset flag, the synchronize flag, and the finish flag. We'll talk more about each of these in the following slide. However, let's just check on the last couple of fields here. So we have our window size. See, TCP allows a certain number of segments to be transmitted before an acknowledgement must be sent back. If you had to acknowledge every single segment that was received, then you may run into some problems of requiring a lot of overhead, a lot of two-way traffic. So if our connection is reliable, a certain number of segments may be transmitted without receiving an acknowledgement, and that number of segments is called the window size. So here we are describing what the window size is. We then have a checksum to do error checking for our packet and make sure that there is no degradation of our data during transmission, and then also the urgent pointer. And finally, the last 40 bytes can be additional options or padding. And recall that these 40 bytes are optional, that the minimum header size is here of 20 bytes, and the maximum size, which is optional, is up to 40 additional bytes, making it 60 bytes long. So let's take a look at these flags just a little more here. So the urgent flag, remember these are all 1 bit. A value of 1 indicates the flag is being flagged. A value of 0 means that it is not. So the urgent flag is to process this packet before any non-urgent packets, to send this packet up the protocol stack to be processed by the application. The ACK flag, or acknowledge flag, acknowledges the receipt of a sequence number. So if our acknowledgement flag is set, we would be looking at the acknowledgement number here to identify which sequence number is being acknowledged. Our push flag is to process this packet immediately and not buffer it. It's very similar to the urgent flag and is really more application specific. The reset flag resets a connection. Now, we haven't really gotten into yet what makes TCP or UDP a connection-oriented or connectionless protocol. We'll be talking about that more in the following slide, but for right now, know that TCP is a connection-oriented protocol, and UDP is not. When a connection is established, we would use the RST flag or the reset flag to say that one of the two communicators wishes to have the connection be reset, that we should end the connection immediately, and we must go back through our connection opening process to establish a new connection. The SYN flag, or synchronize, is the flag that is set when we request to open a TCP connection. And finally, the FIN flag indicates the sender has no more data to send. It indicates gracefully that it is finished. So I did promise in the following slide we would talk about the connection establishment process. So TCP, the Transmission Control Protocol, uses the three-way handshake in order to establish a connection. And this is what makes TCP a connection-oriented protocol. What happens is some sender sends a TCP packet with the SYN flag set. And recall, this requests the opening of a connection. When the receiver receives that packet with the SYN flag set, it will go ahead and reply and acknowledge the receipt of that sequence number. See, this has some sequence number that is equal to a random number. And back here, the acknowledgement number would then be set equal to that sequence number, and the acknowledgement flag would be set in that reply. And the receiver will also look to open its own connection, to reply with a SYN ACK, a synchronize request, and an acknowledgement. And then finally, the original sender receives that SYN ACK and will reply with its own acknowledgement that this SYN ACK would have a sequence number, and therefore the acknowledgement number down here would be set to this sequence number to acknowledge the receipt of that sequence number. This confirms two-way communication with both parties. Both the sender and the receiver, in this case, know that both of them are receiving each other's information. This is what establishes a, quote, connection, is knowing there is reliable communication between each other. So how does this compare to UDP, the connectionless protocol? Well, we're going to go into UDP in significantly less depth because UDP is, well, just a simple protocol. UDP is the user datagram protocol. The protocol data unit is the datagram. It has a header size of 8 bytes in comparison to our 20-byte minimum of our previous TCP header. And UDP includes the source and destination IP and port. So right here is the format of the UDP header. There's no flags, there's no pointers, there's no acknowledgement numbers. All we have are the source port, destination port, length, and checksum. So we do have a checksum to try and make sure that each individual datagram has not had any degradation through transmission. But other than that, we have no mechanism within this protocol to be able to confirm reliable transmission. This is where UDP is connectionless. When UDP packets are sent, there is no mechanism within the protocol to confirm whether they were received or not. So UDP is typically used when we need a small header size with lower overhead, and we don't really care if the transmission was actually received. Something where this would be really useful is in real-time protocols, RTs, our voice transmission. We don't really care if it was received or not because there's no point in trying to retransmit. The time has passed. We shouldn't replay the words that are being said over the voice call. Instead, just continue sending our packets and hopefully the other side receives it. So our voice data is generally encapsulated in UDP headers, our user datagram protocol. Excellent. I really appreciate you going through that with me. I hope that this has been informative for you, and I'd like to thank you for viewing.